Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, we're going to be looking at the file systems again. This time we're going to be looking at 5 different ones, except, we'll retest the ones. We're going to add one new and replace one. The ones that we're going to be looking at, of course, is we're going to look at bcacheFS again, ext4, btrfs. We're going to be looking at Stratis this time instead of FWrite. And the reason for that is, as of RHEL 9.3, Stratis is now fully supported. So it's no longer experimental. It is now a fully supported file manager. And XFS, of course, we'll look at those. You'll notice that I did not include ZFS again. I ran into some issues. I did attempt to test ZFS. I wanted to actually do, and I'll probably still work on this and do it later, but the performance on ZFS is extremely fast. It's faster than the drives are capable of, which indicates that it's performing all of its I/O out of memory. In the latest version of 2.2.4 of ZFS on Linux, there is nothing I can do to override and force it to stop using memory. I've tried all the tricks. So, you're welcome to put any comments you have below as to something else that I might try, but I've tried the System D method of limiting both the memory that it's using, and also I did attempt to even play around with the processors to see if I could slow it down at all. And it was funny, every change I made, it actually sped it up. Let's talk a little bit about bcacheFS. Has had a number of improvements since last time I benchmarked this was back in January, and I was using the kernel 6.7 to do that. And there have been a lot of improvements. There's been a lot of updates to bcacheFS. There's been a lot of updates to btrfs. It looks like those two have been concentrating on this flooding of the sys requests into the system, and both of them are able to run now without bottlenecking the sys requests. We'll have ext4, of course, again. That is a default file system on many Linux distros today, and still continues to be. It's a good all-around file system. Project underway to create ext5. We'll talk about one of the things that they are doing with it that just it makes me want to run from Linux and never come back. So we'll talk about that at the end. Stratis is, of course, we talked about that a bit. It is official as of RHEL 9.3. XFS, of course, which is there has been a lot of changes going on with it. One of the big changes is the developers are adding journaling support to it. It's not done. It's not out. So that'll be interesting to take a look at once that's completed. I know that's one of the big complaints with XFS is it doesn't support journaling. What about RiserFS? I'm sure somebody's going to ask about that. RiserFS is a dead project. And unless there's a sudden spurt in activity, the Linux kernel folks are scheduling to deprecate it out of the kernel in 2025. So, and then ZFS, we talked about that already, so there's no point in hammering that again. What am I testing on? I'm testing on an MSI Prestige laptop. It is an Intel Core Ultra 7. It's a 155H, so it's a Meteor Lake architecture. Has 32 gig of RAM and 2 Western Digital drives that are NVMe PCIe 4. An SN850X is used for both of those, and they're both 2 terabyte. One's used for the operating system. The other one is used for testing the file systems. So yeah, I don't want OS traffic interfering with the test. At the time of this video, I had originally intended to use 6.10, but Fedora hasn't quite moved over there yet. Not sure why. Well, I do know why. There's some bugs in it. I'm using Fedora 40 Silverblue to do these tests, and they're using Linux 6.9.12 kernel for that, so that's fine. I'm using the latest version of IOZone, which is version 506. I am looking at Oracle's VD bench. Process scheduler, of course, is EEVDF, and we've talked about that before. I am using balance. The reason is that on the Meteor Lake architecture, I have shown and Intel recommends you run balance. The I/O scheduler on this is configured to be default, which is none. So that allows the file system to use its best scheduling mechanism that it's built into those file systems. So I'm letting them choose how to manage the file systems versus me telling it, you will use this. So as far as each file system being tested, it is tested from 1 to 5 concurrent users. Don't confuse that with physical users, because concurrency usually means these are 5 simultaneous IOs going on at the same time, which would equate to 50 to 100 users in most rules of thumb. So yeah, and that's how you look at that. So the file systems are configured without encryption. There's no compression, and they are all using direct I/O through IOZone. The system was rebooted between tests. I may do a separate video on RAID. I would like to explore that a little bit. I did want to make sure that btrfs is still not supporting RAID 5 or 6. Just out of curiosity, I did configure a RAID 5 on btrfs, and as soon as I did, I got the message that came up and said, this is unstable, it's not recommended for use, data loss may occur. This is the first test we're going to look at, which is initial write. So initial write is just writing a new file out to the file system. It's sequential. There's no big deal about it. And so here are the results. Anyway, btrfs does pretty well in this. I did notice that this would be where I would see a lot of sys requests going out to do copy memory, and that is no longer the case. So obviously the developers of btrfs have fix this problem, and so yeah, you won't hear me complaining too much about it. And you can see that the performance levels, if you looked at so it is actually keeping pace with ext4 and XFS now. In fact, it is doing better in a lot of cases than those other 2 file systems. One of the big changes is Stratis. Stratis is performing more like XFS. What about reads? Reads should be fairly straightforward, and here again, bcache does not have quite the performance in the sequential reads as the other ones do. But, you know, it is new and it is getting better. It's just not, I think they're still working on it. So one thing I will say about bcacheFS that has been fixed is, I think I told you the last time that it was unstable. If I rebooted the system, the file system would be corrupt and it wouldn't mount anymore. So that problem has been fixed, but the error message still persists. So it still says, I can't read the super block, this is a bad file system, but it goes ahead and mounts it. So I think that's in work. They haven't pulled the error messages out yet, but yeah, the fix is it is working, and you are able to actually use it. So if you do encounter that, just check and see if it is mounted properly before you worry about it too much. As I said, btrfs did pretty well last January, and it still is. ext4 does well in this benchmark, so does Stratis, and so does XFS. So the only thing is that, you know, my only criticism of btrfs is that for workloads that are on workstations, it's a little slow to ramp up. The other file systems, including Stratis, have a definite advantage here on the lower level workloads that you might encounter on your desktop. What about rereads? So those are reading a file over and over again. So yeah, it's starting over, it's jumping back, reading over. That's kind of indicative of kind of a workload that you might see in video or audio editing. On this workload, yeah, we're still seeing bcacheFS lagging behind, and we still see btrfs kind of slow to ramp up. But when it gets up to the higher number of concurrent users, btrfs is doing very well. So is ext4, so is Stratis, and so is XFS. Now, FRead. I always get this comment. That's reading faster than the physical drive. Yes, I know, but that's the point. FReads are buffered. They're stream reads. They're buffered. That's the way they're designed to work, is through memory. You can't turn it off because that's the way it's made. It's made to run I/O as fast as possible, using every trick in the book to stream that I/O out. Bcache does pretty well in this. It's the slowest. It's not the slowest. ext actually is in this kind of a workload. But it is slower than btrfs and Stratis and XFS. As far as ramp up, Stratis has a little bit of, it struggles to ramp up. I think XFS has more of an advantage in this kind of workload in ramping up and then going to a steady state sooner. But you'll notice that btrfs really picks up speed after the second concurrent user. So FWrite, same thing. It's streaming, except it's writing. It's going to be pushing from memory, writing out to the drive as fast as it possibly can. So in this case, you should start to see things like I/O wait times, and you do. And so that actually killed btrfs's performance here, is because the copy on write comes back in at this point and kills it. I did notice the I/O requests went way up at this point. So did the CPU, of course, because now you're managing a pretty deep I/O queue. So there is going to be more processor involved in that. But the other ones do pretty well. So what about mixed workload? This is a mix of reading and writing, so this would be more indicative of maybe a database where you have all kinds of I/O that are going on to update and to retrieve and to create new records. So in this case, any of the ones other than bcacheFS are good choices for it. Again, btrfs still has a slower ramp-up time on single-user workloads, or single concurrent user workloads. Let's say it that way. PRead is a standard. These are standard calls inside of Linux that are part of the kernel, and PReads have the capability to read offset from the file. Typically, you will see these in C programs, probably Rust as well. Common method of reading graphics or zip files, anything that has a header in it, because PRead will read the header and then it'll jump to the portion of the file where like the zip begins or the image begins and starts to process it. Pretty much all of them do pretty well. I mean, btrfs is off the mark a little bit here, but the others, all from ext4, Stratis, and XFS are all doing pretty well here. So whichever one of those that you like the best is probably going to be fine. PRead, it's just the writing portion of it. So in this case, you're updating the metadata and then writing the image. So you could potentially be dropping the whole image out, calculating the size, and then pulling back and updating the metadata once you've calculated the size of the file. So, I mean, I have seen it do things like that. NitFs do that pretty, which is another imagery format. So that's used quite a bit in the scientific community. This case, again, they all four do about the same. It's just there's some that ramp up a little bit better. Stratis and btrfs have about the same ramp up speed, but ext seems to get the jump on the out of the box. XFS is a little bit slow to ramp up here as well. Random reads. These would be random I/O, random files. You might see these in SQL-less databases because they use random IO in order to be able to get to locations in the file. Generally, I have a key of some kind that says this is where the record is in offset inside the file, and then I can read the key and then jump to that particular portion of the file. In this instance, all of them except for bcache perform about the same. We still see that slow ramp up. Only this time with btrfs, it's a little bit slow in both the concurrent 1 and 2 users, whereas the others are the ext4, Stratis, and XFS are all fairly equal. I would say random writes, it's doing the same thing. It's randomly writing to areas within the file. Yeah, and random, the biggest thing there you would see if you're using rotational media is seek time. Yeah, waiting for the drive to come around and finding it on the track. The speeds here, as you would expect, are all pretty good. We still see that little bit of slow ramp-up time that btrfs has. But the rest of them, ext4, Stratis, and XFS, perform about the same. Now, I'm not commenting about bcacheFS. It's performing about where it did in February. Rewrite, same thing here is going on. So this time we are rewriting areas of the disk. So this would be a file that is continuously being updated. So it's posting real-time information into a file. Again, I mean, yeah, we can go back, but it's all of them, all 4 of the main ones do pretty good here. So reverse reads, this would be compilers would be using this a lot. Sometimes it is more efficient to, when you're doing parsing, to use reverse reads and read the file from the end forward. So in this case, again, all 4 of them do pretty well in this, which is a pretty big change with the exception of the ramp-up time for btrfs. I don't see that so much in Stratis or XFS. ext has a little bit of a ramp-up time there that's a little slower than the last 2. Stride reads is you read a portion of the file and then you jump ahead and you read some more. This would definitely be seeks inside of a database for that. So in this case, we have 4 of them. Now, btrfs is a little bit off the mark here, but the other 3 at the bottom are performing about the same. The ramp-up times on the last 3 are about similar. And again, we're seeing that it's not as bad, but it's, it's off. Which one wins? And for this, we're going to take a geo mean of all of those tests and just compare all of the file systems together. As you would expect, bcacheFS is not the winner. It's sitting. I'm not laughing. It's just it's just where it is in its development cycle. So, I mean, it is better than it was, and they are making strides toward that. So that's great. I mean, that's good progress, and they should be proud of that. It's really kind of early to benchmark a file system like this, but it's in the kernel, and so if it's in the kernel, I'm going to use it. btrfs, ext perform about the same, and Stratis and XFS perform a little better and are about the same as each other. So, yeah. So if you're the big difference is that Stratis has additional things in it you can do, like you can create virtual devices with it as well. What about ext5? What's going on with it? Well, it has a number of things that they're doing with it. One is to add built-in encryption and improve scalability. But one of the things I did here that just makes me want to, in keeping with Systemd Eats the World meme, ext5 will be directly integrated with Systemd. With that, I hope you enjoyed this video today. And if you did, please like and subscribe and share it with your friends. And I hope to see you all again in the next video. And bye for now.